In this lecture, we'll discuss about quantifiers. So come to the formal definition. Quantification expresses the extent to which a predicate is true over a range of elements. Okay, so this is a formal definition. Next, the quantifier gives us the power to express propositions involving entire sets of objects, sum of them, enumerate them, etc. Okay. So there are two kinds of quantifiers. One is called as universal quantifier. So this is the symbol by which a universal quantifier is represented. The universal quantifier let us apply a predicate to all members of the universe of discourse. Okay, so here the universal quantifier is applied to all the members of the universe of discourse, or we can say it let us apply a predicate to all members of the universe of discourse. Okay, so we'll understand this one when we take an example for this. Essentially, it let us say things like everyone is happy or all numbers are divisible by 1. Okay, so it is denoted by the symbol for all. Okay, read as for all, and it can be read as for all x px. Okay, so this can be read as for all x px. Okay, for all x px is true when px is true for every x. Okay, so let me write down one universe of discourse. Let's suppose I have a set S is equal to 1, 2, 3, 4 and so on. So let's suppose this is a set of natural number. So let me write it down as n. Okay, let's suppose px predicate is x is divisible by 1. Okay, and for this predicate we have a universe of discourse is n. Okay, we apply this particular predicate in this universe of discourse or the domain, that is the set n. Okay, then if we say for all x px, we know that every number is divisible by 1, so this will be true. Okay, this will be true. That is the meaning of this. For all x px is true when px is true for every x. Okay, so this particular predicate function is true for every x. When you take 1, this particular predicate will be true because 1 is divisible by 1, 2 is divisible by 1 and so on. So this will be true. Okay, so let's suppose you have another, let's suppose you have qx. Okay, x is a prime number. X is a prime number. Then we can have for all x qx, it will be false, because to make it false we can have only one element in n or in the universe of discourse. If for at least if for one element if this predicate is false, then for entire this for all x qx will be false. Okay, so you know that 1 is not a prime number, so no need to check further. So here for all x qx will be false, and the predicate function qx is x is a prime number. Okay, now for all x px is false when there is an x for which px is false. So this is the example we have taken here. To make it false, we have to find out only one element for which px will be false. But to make it true, px will be true for entire element present in the set. Okay. If the domain is empty, then for all x px is true. If there is no counter examples to make it false. Okay, so let's suppose we have the domain. Let's suppose D is empty, and we have a predicate. Let's suppose Rx x is an even number, and this particular predicate we apply this particular predicate function in this universe of discourse or on this domain D, but it is empty. The domain is empty here. Then for all x Rx, okay, for all x Rx, this will be equal to, this will always be true, okay, because there is no example or there is no counter example to make it false, because there is no element here. Since there is no element, we cannot have a counter example where this particular predicate function Rx will be false. Okay, so if the domain is empty, then for all x px is true if there is no counter examples to make it false. Okay, come to an example. Represent the following statement in predicate form. The statement is every city in India is clean. Okay, so we have to represent in predicate form. Okay, so let's suppose we can have UD means universe of discourse. Universe of discourse. So this one is nothing but set of Indian cities. So universe of discourse, this set, you can take any representation. It will be Sn. I have taken UD. So this is set of Indian cities. Okay, so all the Indian cities are present in this particular domain or in the universe of discourse. Okay, now let us define the predicate function. So let us suppose Cx. Okay, Cx can be defined as x is a city in India. Okay, and let us define another predicate, that is Lx, let's suppose. So we can have x is a clean city. Okay, so we have defined two predicate functions, Cx, where x is a city in India, Lx, x is a clean city. Okay, so now we can have for all x, okay, if x is a city in India, then it is clean. Okay, so this is the this statement is represented in the predicate form as follows. So for Lx, Cx implication Lx. So it can be written as, or it can be read as for all x, if x is a city in India, then it is taken. Okay, so very simple. To solve this kind of statement, first of all, you have to break it up in different predicate functions. Then according to this, we'll use the universal quantifier here. Okay, then one logical connectives, that is implication here. Okay, come to another example. All natural numbers are divisible by 1. Okay, so here let's suppose universe of discourse n. We've taken n is set of all natural numbers. Okay, in the bracket write down it's a domain. Okay, so whatever the value of x, y, or any variable we take, that will belong to this particular set n. It's the domain. Okay, so let's suppose you have ax. Okay, so here x is a natural number. Okay, then we have, let's suppose dx. X is divisible by 1. Okay, now let us represent this particular statement in predicate form. So we can write for all x, if x is a natural number, then it is divisible by 1. Okay, so it can be written as for all x, if x is a natural number, then it is divisible by 1. Okay, so in this way you can represent it. Okay, so we come to one notes here. For all is usually associated with implication. Okay, so whenever this universal quantifier is used, so it is usually associated with the logical connectives that is called as implication. Okay, common terms. So in this statement, the common terms which are used are for all, for every, for each, all of, given any, for any, etc. If this kind of common terms are used, then it will be clear that you have to use universal quantifier to express the statement in the predicate form. Okay, so this much for today.